Hello everyone. Today I'm going to give a demo of brain tumor detection using EEG wave patterns. So in this we have taken the data set of EEG wave patterns, and training is done through the neural network and testing is done through the GUI. So initially we have collected the signal forms of data set. So now we go for the code. Type ideally call open, file open. So this is the node where we have collected the dataset initially in CSV file. So this is the dataset we have collected. For this display for one level. So we can see the dataset of brain tumor EEG wave values. Dataset is in CSV file, where X is the input, Y is the labels. Based on that, it will generate the signals. You can see the labels. Here you can see the labels. So totally 5 labels are there from run model. So this is the signal form of EEG wave patterns. So this is how we collected the data set of each image. And now we go for the training code. So that you can see the data set. Once we converted the signal form, we have collected the data set here. The 1 stands for area of the brain tumor, 2 brain tumor, and 3 for eye closed, and 4 for open eyes, and 5 for region where the brain tumor occurs. So totally we have collected the 5, and this is the dataset folder. And here we are loading the dataset, images. After that, we are converting the each image into the array format. And then to categorical, it will convert the targets. And here after loading the files, we are splitting the dataset into train and test files. And in this part, we are displaying the total categories, total images, training images, and test images. And in this part, we are loading the RGB image as Python image library using image. And after that, converting image into the 3D stands for height, width, and 3 channels. 3 channels stands for red, green, blue channels. After that, 3 channels to the 4D tensor it will convert. And this part we will display the graph, where X is the accurate epoch, Y is the accuracy. And upper left, we have mentioned train and validation. We display the accuracy and also validation accuracy. And this part we will display the loss and validation loss, where X stands for epoch, Y stands for loss, and upper left stands for train and validation. This part is used for the train we used input layer, hidden layer, and in this we have used NB filters 32 and NB filters 264, and finally we will convert 2 dimensional to 1 dimensional Softmax is useful to classifying purpose, and model compile is used to increase the accuracy. So this is the parameters, loss, optimizer, and matrix. And model.fit is used to train and test targets. Where added validation split is 30 means 70% is the training and 30% is testing. And this is the iterations and BAS is number of sample images. Now click on run model. So you can see total categories 5, number of categories and total images and also training and testing images. Here we mentioned about 100 till 100 iteration, the process will be continued. So you can see the graph of train and validation. This is the loss. So you can see the accuracy. For the testing goal. This is the library used to create the GI. Content model. Load the image from the dataset. So here you can see the original image, gray conversion image, configuration. So you can see predicted images train tune. Can check for another. You can see original image and train image to configuration. You can see predicted images open as